Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things I'd like to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on the Microsoft Reactor YouTube channel in 24 to 48 hours. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and I'll now turn it over to our speakers for introductions.
Awesome. Thank you very much indeed. Thank you. So welcome everyone. Hello, good morning, good afternoon, good evening, wherever you are in the world. Welcome to today's session, which is going to involve IoT, cows, AI, and maybe a little bit of poop. So we are marking this as suitable for mature audiences only, simply because we will be talking about poop. Yes, you never thought you'd get that from Microsoft. We're going to have a session about poop. This isn't Ask Me Anything. So this is a session where please join in, throw in your questions, and we can take the conversation wherever you want to go. Now, I'm super excited. This is going to be a really cool session. I'm joined by an awesome person who has built some really, really cool dairy farming, technology, solutions, poop management, whatever you want to call it. Glad to have Bryn Lewis with me here today. Bryn, do you want to introduce yourself? Say hello to everyone.
Hello, my name's Bryn Lewis. I'm a Microsoft MVP based out of Christchurch, New Zealand. My specialist areas are Windows Dev and Azure IoT, and I work for a smart ag startup for half a
Nice.
week.
So smart agriculture. So this is kind of bringing IoT into agriculture. Something I kind of talk about a lot whenever I'm doing introductions to IoT. I kind of talk about how IoT is empowering agriculture. And this is kind of what you're doing. You are taking one of the oldest things humans have been doing, for thousands and thousands of years, and optimizing that for our growing world, essentially.
We have multiple sites dotted over the Canterbury Plains where we're using a combination of machine learning and process control to manage flow control through dairy milking sheds. And
Right.
we have some other projects which are coming in the future to improve farming and its ecological impact and production.
Nice. So it's not just it's about optimizing farming. It's about allowing us to do more with what we've got, but also ecological impacts. So we think about the environment. Farming is kind of hugely damaging. So it's kind of quite cool that you're thinking about the environment as well. So I do want to take a moment to just give a shout out to a few folks who've joined us. So David has joined us from Melbourne at 0 degrees Celsius at 8 a.m. A bit chilly on the other side of the world. I've got family in the UK. I don't live in the UK anymore. I've got family there where it's 40 degrees Celsius. So I bet they're kind of jealous about your temperature. And Babita Sina says, good evening, Jim and Bryn, joining us from the USA. Welcome. Glad to have you here. You joined my stream yesterday, if I remember rightly. Was it yesterday or was it Friday? These days will blur into one. But welcome back. And Alan McElroy says, good morning from Brisbane.
I think my CEO's out there somewhere.
Sorry?
I think my CEO's out there somewhere.
Yeah, okay. If Bryn's CEO is out there, say hello. We promise he'll be on his best behavior for this entire session. Cool. But yeah, please jump in the chat, chime in, and ask any questions. Bryn is an absolute expert here, so we're really privileged to have him with us to answer any questions you've got around smart agriculture. But yeah, so do you want to just kick off and talk a bit about some of the projects you're working on?
Yep. Initially, I figured I'd focus on the dairy shed automation project, and then as long as the CEO's not paying attention, we might have a chat about some of the future stuff.
Nice.
I guess if anyone was interested in me, they would have read my profile, but just to introduce myself, I started in the computer industry the year that Never Gonna Give You Up was released.
I think that's the first Rickroll we've had on
in
a while.
I did have a video. It was released in the UK in July 1987, but it didn't become #1 in New Zealand until the week of the 7th of February. And that was pretty much the exact week I started in the IT business. I'd been at uni. I was doing a 3-year degree, but due to going feral in the first year, it turned into a 4-year degree, and I needed to earn some money to fund my final year. So I ended up working in a path lab, a pathology lab, attached to 3 hospitals here in Christchurch. After a couple of years working there, my claim to fame was taking out the computer system which ran all 4 labs. For those of you who've been in the industry for a while, there was the brown line flow paper, had brown stripes on it. I was standing in front of a Unisys A5 mainframe, and I accidentally dropped the A5. It was called concertina paper down the front of the disk pack, and the disk pack went, "I'm hot now, I'm shutting down." And then my boss walked in, said, "Oh my God," picked up the phone, turned it through 90 degrees on the top, and then we spent the next quarter of an hour bringing back up 3 pathology labs. All the automated machines had to be reconnected. It was just a world of pain. So that's my claim to fame.
Nice. So a few more comments in the chat. Jay Templeton says, "What's up, Jim and Bryn?" Hey, Jay, long time no see. Glad to have you join us.
At one stage, Jay was my boss. And I worked with Jay at Microsoft Consulting Services in Auckland in the early thousands.
Yeah, I worked with Jay on some FarmBeat stuff for a hackathon at Cornell University. Back when we used to go to things in person. I actually got to hang out with Jay at the event there. So great to have you here.
I worked on FarmBeat's student kit.
That was the same kit. Same kit we're showing off. Nice.
A long time ago.
Yeah. Kyron Evans says, "Good morning. Welcome. Glad to have you here." To Sales says, "Kingsley, hi from Sydney." So great to have the Southern Hemisphere contingent here. Normally we get a lot of folks from Europe, so kind of nice to do a session where we can get folks from New Zealand and Australia. Great to have you here. Jimmy says, "My friend has also done a similar project called Internet of Cows." Nice. Instead of Internet of Things, it's Internet of Cows. It's pretty cool. Richard Appleby says, "Good morning." Hey, morning, Richard. Glad to have you with us.
He's my CEO.
He's the boss. Okay. So it's amazing that Bryn's here today, Richard. He's awesome. You know, I'll keep putting in good words from all the time. Cool. So you've got a picture of fields. Talk me through this. Is this an average farm setup?
Yep. Richard drew a bounding box around what we consider as an average farm. It's basically a big outdoor factory which costs a lot of money and is exposed to the vagaries of wind and weather and international economics, wars, pretty much every global event. So if you wanted to build your own dairy farm, you'd need sort of 220 odd hectares. This one's about 216 and it's 50K a hectare. So your land is about 10.8 million Kiwi. Right. For those who wish,
6.5 million US, I think it is.
Yeah, about 0.6. You'll need some cows, and that's probably about 650 at 1,500 a cow. So that's 975K of cows. And then you'll need a few center pivots for irrigation. 800 meters is common. A span is about 40 meters, and then a span costs about 15K. So 800 meters is 20 spans, which was about 300K.
And that's for the, because you've got like circle shapes going on there.
That's with the center.
Sorry, excuse me one second.
I'll keep on going.
Always when I live stream, someone brings out the power tools. Let's shut the window. Because you've got the kind of circle shapes going on there. So this is what you're saying about the center pivot. So this is where the irrigation thing's like basically like a big pole that goes round with a sprinkler on it. Is that right?
Yeah. Some farmers use wells and pump the water up out of wells, and other farmers own shares in irrigation schemes and so forth. That 300K for the center pivot doesn't include the cost of pumps, ponds, and consents. Farmers have consents to take water and consents to discharge effluent. Right. You'll need a milking shed, and a milking shed is somewhere between 1.7 and 2 million. These are a boutique thing. Everyone is custom, and they're a huge, expensive piece of kit. Some are anti-clockwise, some are clockwise. Everyone is different. We are yet to see 2 which are the same. There are 2 different designs. There's rectangular yards and round yards. So far, we've done mainly round yards. All up, it's somewhere between 12 and 15 million Kiwi, which is a big pile of cash.
Yeah, so that's about 10 million US dollars. 8 million euros. No, it's 1-to-1 with the euro now, so 10 million euros. So that's a lot of money to set up a dairy farm.
You basically are on your first name terms with your bank manager. There are some dairy holding companies which own half a dozen farms, so it's some sort of huge investments going in. So this is a rectangular yard, and this is where our software works. You can see the blanked off bits. That's us blanking off where the cows enter and exit the yard. And for perspective, that's a farmer standing at the very back by the gate.
That little tiny thing in the back there, that's a farmer.
Yeah. So that's about 80 meters. So we're dealing with some fairly large pieces of kit. This is a round yard. It's about 30 meters across. And in a round yard, there's usually 3 gates. At around 270 degrees is the backing gate. As the cows come around the yard, they come in on the top left. As they come around the backing yard, the cows exit the yard to the left onto the milking platform. The main gate, the backing gate is at roughly 315 degrees. This moves the cows around the yard towards the main gate. And then the top gate, which has some dangling chains and is used to incentivize the cows to move towards the main gate. When the backing gate gets to the main gates, they swap roles and the main gate becomes so forth and so on. And the yards can operate clockwise or anti-clockwise. It just depends. I was chatting to Rich and he said it's basically where the milk truck comes from. Inside the shed, there's some more hardware. Outside the shed, in that case, there's a generator, silos for feed, and pumping equipment for water.
So this is how you basically feed the cows into where they're going to get milked. You've got a whole field full of cows. You're going to bring them in, stick them in this circular contraption, and guide them into the milking shed where you take the milk out.
Yeah. Cool. This is looking across a rotary shed at ground level. You can see the top gate. It goes above the cows' heads, and then there's the main gate and the backing gate. The main gate is the one on the right. The backing gate is the one on the left. We put most of our kit on the face shear boards of the garage just ahead of us. You'll see there's a lamp on the right, a spotlight, sort of cameras around there, another one high at the top, and then we connect into the electronics or the electrics, which controls the gate. You can see the yard has a good coating of poo.
Mm-hmm.
Tick. One reference to poo. The yards are regularly washed down either by humans or by spray assembly on the bottom of the gate. But for a townie like me, the smell is pretty bad. I had to buy some gumboots for my first trip to the farm. I really should have taken them to them with a piece of sandpaper so people didn't pick me out as a townie as soon as I arrived. In summer, the water evaporates and the poo dust gets into everything. Second poo reference.
Nice.
This is the milking platform. In an average sort of size, normally there's sort of 50 to 80 bales. In an average world, there are about 60 bales. The cows step onto the platform and it rotates, and then the cows step off and head back out to the field. The mechanics behind this are pretty phenomenal. Cows weigh somewhere between 450 and 650 kgs. So an average platform with 65 average cows on board weighs at least 36 tons. Wow. It runs on some giant bearings, and every few years they have to jack the platform up and replace them. So it's a fairly good piece of engineering. Some farms have troughs in the middle with food, so the cows eat as they're getting milk. And this is great because it incentivizes the cows to get up onto the platform. And this is where the magic happens. There's still more poo. The cows come across the bridge from the yard. As they go past the milker checks the teats. I don't think there's one there. Some cows have a combination of bandages on their legs, and this indicates which teats are out of service. They check the teats, they put on the milker wear, they start the milking. The cows chill for roughly 8 minutes. Then usually the milker wear drops off and is pulled away by some machinery. The cow steps off the platform and heads back to the paddock. While putting on the milker wear, setting the milking off, the milker is looking up into the mirror on their right hand, above their right hand shoulder, and figuring out what the density of the cows is in front of the bridge. There's some discussion about whether they're looking at the density and they've just subconsciously figured out the best, or mooing. If the density's too high, the cow's heads rear up and they moo. So there's a combination of the two different ways of looking at the density. There's also a bit of a delay between when the gates move and when the density increases. So it's fine art, and some milkers are good at it and some milkers aren't so good at it. In New Zealand, a lot of the milkers are from overseas, the Philippines, countries like that. So when they arrive in New Zealand, it takes them a wee bit of time to get the hang of it, and some never do. This is the current user interface. It's smeared with poo.
It's pretty kind of, it's not a sensitive touch panel, isn't it? Whatever you're going to have for this, it's got to survive in some extreme conditions, I would guess.
Yeah,
being smeared in poo is fairly extreme.
It's not a nice React app running on your iPhone.
Johnny Ive would not be very happy with this, would he?
No, the poo's the wrong color. All the equipment around the platform needs to be pretty robust as it's exposed to the weather. The end of the milking shed is exposed. Some milking sheds are more problematic than the others because of the prevailing wind flows. And also this gear gets hosed down. Down south, you'd expect maybe -10 in the sort of the beginning and the end of the season. And summer, maybe 40 degrees.
Wow.
Yeah.
So that's a big range, -10 Celsius to 40 Celsius. That's quite a big range.
Yeah, it's pretty unpleasant. We've had some problems with the gates. The gates are moved by some motors on the end, and you get problems with poo lubricating the track that the gates run on, and also ice. This is the milker's user interface. They control the gates and the speed of the platform. So the aim is to get the platform going around at a sort of about 8 minutes. And that gives the cows enough time to step on and get milked. Once the platform's up to speed, they pretty much ignore the speed for the duration of the milking. We have another control panel, which is also smeared with poo. And on our control panel, the milker can start and stop mover, our application, plus transition and reset the gates. So at the beginning of a milking, you can set the gates back to a known position, which is important. And then as the milking progresses, you can do the transition, which is where the main gate becomes the backing gate and vice versa. We also have some lamps to show that our software is running. So we're not using Maui. We're not using CSS. We're not worrying about positioning pixels. Basically, it's got to be resistant to being hosed down.
Okay, so it's not about a flashy user interface, is it? It's about resiliency is the most important thing. So who cares what the UI looks like as long as it's waterproof and -10 to 40 degrees proof and poo proof?
Yeah. Milkers are renowned for trying to fix everything with a length of alkathene pipe. If you hit it hard enough with a piece of alkathene pipe, it will spring back into life again.
Percussive maintenance, as they like to call it.
Yes. This is our API. You'll notice there's no Swagger, there's no gRPC, there's no XML RPC. Basically, it's a switchboard. Every shed is a boutique, handcrafted arts and crafts piece of kit. There are a couple of different vendors, but everyone is different. One of the nightmare ones is where the shed was built and then it had a fire. So half of the shed was wired by one vendor and half of the shed was wired by another vendor. We put a fair bit of Cat5 into the shed. We install a small LAN switch, some PoE cameras, a PC-based device for running the core software, the box with some lamps and some buttons on it, and a PLC, a programmable logic controller. We use a couple of different brands, and this is our interface into the physical stuff like the gates and the washdown control system.
So this is literally an IoT install. This is, often when we talk about IoT, we show off like dev kits, like, oh, look, I've got a Raspberry Pi with this on it. But when it comes to the real world, a lot of it is just kind of this custom install because every setup is different. Every factory is different. Every farm is different. So although there's probably a core set of components, how you connect those up is different. And then, as you say, you've got your PLC that connects to external hardware. All that external hardware is going to be different in every single farm, isn't it?
Yeah.
So there's a lot of customization.
There's also supposedly as-built documents, which are produced by the vendors of the infrastructure in the sheds, but they lie. Nothing is right, usually.
Yes, it's like the old documentation in software, isn't it? You end up writing docs that are completely out of date. The documentation here is the actual hardware itself.
Yeah. We have electricians who've become reasonably proficient at reverse engineering what's going on and then installing our kit into the milking shed. That's one of the issues we have, is because we have kit and interfacing into hardware, we're effectively a services gated organization. We have electricians who have to drive out to the farm, figure out what's going on. They have a cherry picker or a scissor lift to get the cameras up, things like that. So there's a reasonable amount of scheduling and programmatic stuff that has to go on to get a system installed. And then there's a period of training while it learns how the farm works. So hopefully this video will work. So this is our system in action. You can see the gates are moving around, the cows are moving out, and they're exiting just about the middle of the screen. This is from one of our test farms. And you can see that
the mouth, the Pac-Man opening up, and the chains you're talking about kind of just pushing the cows.
Incentivizing,
yes.
And then you can see the final bit where we can't actually control the process that well, the last few cows going across onto the platform.
So Richard says, in 20 sheds, I have seen 0. So I guess in 20 sheds, I've seen 0 similarities between everything. Is that what you mean?
Yeah. We use the Azure Python client for provisioning the devices. We use Azure Iot Central or Azure IoT hubs. We send telemetry up to the Azure IoT plumbing, and we upload images to Azure Blob Storage for post-processing and generating videos like that. We use Azure Application Insights for monitoring the PC and application health and real-time monitoring of some of the system decisions we make. Morning milking is usually sort of 4:30 in the morning. So if something breaks and a milker's shouting at you, you really want to get on top of it quickly. We use Azure Iot Central for displaying some telemetry and some calculated metrics, and then also some alerting. So when things go wrong, we know about it just before the milkers start shouting at us.
Cool. So Richard has confirmed to say documentation. So in 20 sheds, Richard has seen 0 documentation.
Yeah.
So the hardware is that documentation.
Yeah.
So I have questions about this. So you're saying using the Azure Python client. So you said it's like a PC. So is that the control center is just a PC? You're not coding up any microcontrollers. You're not, nothing like that. You literally got a PC run everything. So you're doing Python on the PC. Is that?
Yeah.
So what was the reason for choosing a PC? Are they ruggedized enough?
Yep. Basically, we wanted to build as little custom hardware as possible, because these systems have maybe a 5 to 10 year lifetime, and anything custom we build, we can't get support for. So it was off the shelf. We sit down with a vendor's parts list. We adjust what we need or what we're going to buy. In these days of supply chain problems, we're actually using 2 different vendors' brands of PLC. We were trying to standardize on one, but we couldn't source all one.
Yeah. Okay. So you're running a PC, running the Python client, and that feeds everything up to the cloud, and that's where you do all the processing and alerting. And I guess Iot Central is great for that because it's instant dashboards, drag and drop dashboards, and then setting up alerting is easy. You don't need to be an engineer to set up alerting. Anyone who's an operator of the system could add an extra alert if they want it.
Yeah. It gave us a quick and dirty way of getting some eye candy for Richard.
Yeah. That's always the way. The CEO wants the eye candy. So,
So this is the system at work. The aim is to have somewhere between 1.2 cows per, a cow per 1.2 square meters for smaller cows, or a cow per 1.5 meters squared, just in front of the bridge to the milking platform. We need to tweak this for each farm because each farmer has a different view on how it should work. The green stripe is the optimal range, us keeping it in the optimal range, but we struggle to keep it in the optimal range as the yard is filling or emptying. The solution seems to work pretty well in the farms that we've tested. An average milker spends about 126 minutes a day in the shed, and we reduce that, we think, by about 25%. An average dairy farm, and these are all sort of approximate numbers, which are very New Zealand and maybe even Canterbury specific. An average dairy farm spends about 25K a year on power, and we think we reduce that by roughly 25%. The milking gets faster as the cows learn how milking works. The cows are happier, less lameness, and because the operation of the yard is consistent for both different staff and different staff members on different shifts, visualize someone trying to run a milking platform when they've got a really bad hangover. It works really well. It's a positive reinforcement loop once the system's up and running.
Nice. So, I mean, this is quite a big difference. This is kind of one of the drivers of IoT is how can we reduce the time to delivery? How can we save money? How can we be more efficient, whatever we do? And how do we look after things? Whether it's predictive maintenance on machinery, or in this case, it's happier and less cows with less lameness. This is kind of one of the big selling points of IoT is we save you money, we make things more efficient because we're monitoring, we're controlling the process. And then because to monitor and control the process, it's got to be a well-defined process, hence why your operation becomes more consistent. And everyone who, once you do one shift, you can do any shift because it's all consistent with how everything works. So this is kind of a nice summary of why IoT is a good thing.
Well, back to the poo thing.
Back to the poo thing.
Yeah. Is anyone keeping track of the number of poo references?
I don't think we are, but it's a fair amount of poo. If anyone who's watching has been tracking the poo, can you give us the current poo count? It'd be good to hear what the current poo count is.
So once the system's installed, physically installed, we have to do a bit of training just to train the system for the location, the type of cows. We've had some problems around that. And this was one thing we weren't expecting. After milking 1,250 cows without a system, the yard looked like that. There's plenty of poo.
Yeah.
Then at another farm, after milking 1,000 cows with our system running, the yard looked like this. A lot less poo.
A lot less poo, yeah.
If cows are stressed, they poo. If the cows arrive at the yard and something's different, they shit themselves. Basically, poo is an indicator of how happy the cows are. If you change the layout of the yard or the way the gates are operated, there will be more poo. It takes 30 to 50 litres of water to put a cow through a milking. And we think that with the less time milking, there's also less time cleaning up and less water used cleaning up, which is a good thing because farms have to get a water right to pump water. Pumping water costs power, yada, yada, yada.
So there's a big cost increase just in the water and the power. And I guess going back to you saying the point about this for environmental friendliness, you've got to wash that poo somewhere. And it's not like you can just wash it off and wash it just into a river. You've got to manage that poo outflow, haven't you? So by having less poo, it's less to manage.
So this is a 25,000 litre lake of poo.
Not a good place to go swimming.
No. It is a truly unpleasant thing being downwind of it. In the back, you can see a centre pivot. That's only a baby one. It's maybe 3 or 4 sections long.
Right.
So that sweeps across the paddocks watering. Managing the poo on an average farm costs around 51K a year in pumping and staff time, which is a fair bit. That's like a staff member's salary. We think that Mover reduces this by about 12%. So less poo reduces costs and the environmental impact of the dairy farms we're installed on. We had some stuff that we weren't expecting found some stuff after we deployed the system. Cows with snow on their back are really hard to count. Algorithm YOLO model, just threw up its hands and the count went badly wrong. We had a farmer ring up and say, hey, you're pulling the cows a bit tight close to the bridge. So Kyron, my co-worker, dived in, and a raindrop on the lens makes it really difficult to count cows.
Oh, this is kind of highlighting some of the real problems with vision-based AI systems, isn't it? It relies on good data, but if you've got no good inputs, if the data is different, what you're testing on is different from what you're trained on, or if there's something that affects the image, it all falls down, doesn't it?
Yeah. There's a classic, I can't remember who said it. In theory and practice are the same, but in practice they're not.
So there's a few comments actually before we dive into that. Raj Srikanth says hello from Sydney. Welcome, glad to have you here. But Babita Sinha asked an interesting question. Poop can be used as a fertilizer for the plants. So can they use that? Can the poop they wash off, can you then use that to fertilize for horticulture?
It requires some care. You don't want to put too much poop on a paddock, and then you have problems with the poop washing off into waterways and things like that. Poop management is a science in itself, and it's something I really don't know that much about. The good thing about the dairy industry, particularly in New Zealand, is it's a cooperative, and there's the expression, the rising tide lifts all boats. So the farmers work together, they explore different approaches for managing poop, feeding cattle, treating mastitis, things like that. So it's quite different to the other industries I've worked in, where it's been a bit dog eat dog. The management, we've been chatting with people about, farmers have dedicated paddocks for spreading the poop on, things like that. The whole management of poop is quite important to farmers.
It's not something you kind of really think about. Yeah, you think about dairy farms, and like cow goes in, milk comes out of the cow, and you got to make sure the cow's happy. But yeah, poop is quite a major consideration.
It's with the factory metaphor. Basically, you tip in water, you make grass, you feed that to cows, the cows make milk, byproduct is poop. The milk goes off to be processed, converted into milk powder or other cheese, yogurt, things like that. And then you have to deal with the poop.
So as grass goes in one end and poop comes out the other, whether it's human poop or cow poop.
Yeah. And then you need to manage that poop in a responsible way. And you need to do stuff like keeping the cows out of waterways so they don't just poop in the waterways. There's the different dairy companies. There's 3 or 4 main dairy companies in New Zealand. They have documents which specify how you need to treat your cows, the procedures and practices that you need in place to manage your livestock, and how you need to manage your poop to reduce the environmental impact of that.
So it's a well-documented thing. That's, as you say, there's poop scientists that manage all this. I
work with another company who specialize in water rights. One of the inputs is water. Some parts of the country you need to either be on an irrigation scheme and get water to spray onto your fields. There's a large dairy farm for sale just to the south of Christchurch. One of the things they list is how many cows, how many hectares, how many shares in the local irrigation scheme they've got, and then the kgs of milk solids they produce every year. And that's how you basically work out whether a farm is viable or not. And you think about what your interest payments are going to be on that $10 to $15 million now in an inflationary period where effectively interest rates are doubling. So using another expression, as the tide goes out, you'll see who's wearing togs.
Yeah. So there's kind of a whole lot of economics you have to think of just around that water management in and out, and because it's a very low margin business as well, isn't it? You know, and certainly from back in my time in the UK, there was always complaints that milk was really cheap and it was putting the dairy farmers out of business. And they were essentially losing money. So, you know, in times of high inflation, why would you invest in a dairy farm? Especially if the water's very expensive for it.
There are both corporate dairy farms, and some of the large corporates own, dozen farms. And you think about that, that's maybe 100 million plus in infrastructure. And then there are family farms. And sort of different attitudes. The corporate farms have a manager. The manager provides all the bikes and the utes and stuff like that. Whereas a family farm, it's most probably all owned by one family, and they look upon themselves as stewards of the land through multiple generations. I went to a school with a reasonably strong agricultural economics department, and you'd see parents figuring out how to gift the farm to their children, and then there'd be one child who liked the farm and the other four who hated it, and then that child would have to buy their brothers and sisters out, things like that. So there's quite different approaches to managing the farms. You have share milkers who bring the cows and some of the machinery. And then in New Zealand, around the beginning of June, there's Gypsy Day, which is actually maybe a week or a fortnight, where everything stops and trucks cart the cows from one farm to another, and then it all starts spinning up again. My boss used to run a dairy farm over on the West Coast, which is a pretty good place to run a dairy farm because it rains a lot, but then there's issues around land quality and drainage and so forth. So that's largely the application we work on. A machine learning product which uses YOLO models to count cows, move gates, and manage the flow of cows through the dairy shed.
Nice. This is kind of a really good classic example of AI and IoT. You've got a YOLO model to identify cows that just manages the volume coming through, and that just controls classic hardware. You just literally say PLC to a big mechanical gate to power everything around. We had a question in the chat from Alan McElroy, who says, have you looked at water and or compressed air for cleaning the camera lens? E.g. for a surfing video filming application, they found that continuous flow of water over the lens was the best solution. So how do you deal with a droplet of water on the lens? What solutions have you tried?
We have a couple of cameras on the site, and some of the cameras have also got heating elements built into them, I think.
Right.
I've been playing around with a camera which has PTZ, pan tilt zoom. Mm-hmm. So we've got different techniques for getting around the issue of water. Our system isn't mission critical. If our system, what's that the hosties say? In the unlikely event that our system fails, the milker can keep on manually operating the system.
So they've got like a big button they can press to turn everything at their own pace, essentially.
So, this is, because the milking shed's a pretty hostile environment, this is the style of the kit we use. This is an actual kit, but this is some kit that was purchased and then ended up on my desk so I could have a play with it. We use fanless industrial PCs. Remember back at the beginning I mentioned dry poo dust. Mm-hmm. So you don't want a fan sucking poo dust through your computer gear. This device here is from Asus, a P100. If any of you have got an Azure Percept, the early Azure Percepts had a P100 as their processing box.
I did not know that.
Yeah, I didn't realize until I had to flash my Percept and update it, because the processors are pretty much the same as an Asus P100.
Oh, nice, because just looking at that, there's a lot of heat sinks on there, which I guess why it can be fanless, because the shape of it, it's got that kind of classic heatsink shape, so you're releasing a lot of heat out of there.
There's also a silica gel bag to connect the processor to the heat sinks, and then on the left-hand side there are a couple of LAN sockets and the power button, and on the right-hand side, which you can't see, there's where the power brick plugs in, and it's also got 8 digital I/O, which we don't use. Part of the problem with using digital I/O on this sort of kit is isolation. You've got big electric motors controlling the platform, and when they start and stop, you can have some problems with voltages being induced in your wiring.
Because there's quite a lot of power needs to be used. This isn't like, you're not like lighting an LED or turning on a relay or anything. You're connected to systems that move big gates, and that's a big power draw. So that's going to
the gates weigh half a ton. So you really don't want to screw it up, and you don't want to get anything in the pinch zone. And then, more coarse language, there are asshole cows. Because cows are smart, you know how there are smart assholes. Some, you get the...
Maybe a bit clean on the language, I think.
You get cows which lean against the gates and stop them moving. And then you also, Boss was explaining, he had a cow which every time you put it on the milking platform, it would lift up its leg and flick off the milk aware, and then it'd spend its 8 minutes on the platform and then head back out to the paddocks. So some cows are quite smart, and the odd cow will be a nightmare. You need to have weatherproof gear, so the cameras are IP67 rated, and then you should really have proper industrial PoE gear. All of the plumbing needs to be in ducts. Sorry, all of the electrical cabling needs to be in ducts. You need weather-tight junction boxes and stuff like that. We also need to keep an eye on the hardware and software we use. It needs to have a good LTSC because the solution has a 5 to 10 year life. One of the things that really worries us is bricking a unit. If we brick a unit, there will be stress, and someone will have to drive for an hour or two to a farm to fix it.
Yeah, because New Zealand is not, although it looks small on the map compared to large countries, it's not tiny, and farms are very well spread out, aren't they? So you're never going to be that close.
We have we can use the farmers' rural broadband, which is good. That's usually 4G based or rural wireless, which gives you enough performance to watch Netflix, but often they've got data caps. The devices, we've been talking about making them courier bag deployable. So if a device dies, we put it in a courier bag and courier it out to a farm. There are some devices which are critical to the system functioning and other devices which aren't so critical, so we can replace them on the fly.
So literally you could just, the quickest way is to put it in a bag, send a courier down with it, and they just unplug the old one, plug in the new, and it just fires up and just works.
Yeah, we use DPS, device provisioning service. So as the device wakes up, it works out where it is and what's it's doing and provisions itself. We can use DTDLv2 in the device provisioning process, so the devices are automatically provisioned into Azure Iot Central.
That's kind of one of the nice things that Azure IoT has, is you've got this ability to automatically provision devices. It knows what type of data it's got to send. As long as it's got the right certificate on there, it just connects and just works, doesn't it? Which is pretty cool.
We don't actually use certificates because it's too hard.
Fair enough. Or if you put the right SAS token in rather than certificate,
Yeah. One of the things with certificates we found is time. You have to have super accurate time because you've got a 15-minute window either side for a TLS connection, things like that. So we just use SAS keys. It's a compromise we made. A lot of the software we focus on, stupid code does little well. Yeah, that's got two meanings, but we focus on simplification.
Yeah.
It's not a lot of DI. There's not a lot of complex design patterns. It's basically a straight line. Go to the cameras, read an image, do the math, control the gates, repeat until bored.
Yeah. So nothing too complicated, because the more complexity you add, the more potential there is for support. So the less lines of code, the less potential for bugs.
My superpower is stupid, so I can help.
I will have a t-shirt.
I can help a lot with that side of the project. We have a full-time developer. The CEO is also in charge of sales, and I just wander in and out for a quarter FTE.
Yeah. Okay, so it's quite a small team. So this is quite an effective IoT solution, built to be as simple as possible with a small team that is enabling savings across, quite substantial savings across dairy farms.
Yeah.
It kind of shows the power of how much just a simple IoT solution, how much impact that can have, really.
Yeah, we could move a bit faster if there was more of us, but realistically, we're gated by how quickly we can get gear out onto the farms. And there are farmy things which slow us down, like currently it's calving, and that's 8 weeks where the farmers are somewhat distracted by the process of calving. And we also have, because we do lameness, we've got some strong proponents among vets and lameness specialists. Farmers have to submit reports to their cooperative milking company or milking organization, talking about animal welfare, condition scoring for the cattle beasts, and lameness. There's been some discussion about whether round yards are more likely to cause lameness than square yards. if a cow gets mastitis, you have to treat it with drugs, and depending on the drugs, you have to throw the milk away, things like that. If there's bad grounding and there are some differential voltages in the yards, the cows really don't like getting onto the platform and being milked, and that can cause mastitis as well. There are things that we've noticed and other people have noticed, often like us in the poo, incidentally as a part of automating other processes.
This is kind of one thing I keep banging on about, is that as an IoT engineer, some of your best friends are like data scientists and machine learning engineers, because your IoT generates a whole lot of data. And there's so many patterns you might find in that data, like the levels of poo, that, but just by having somebody who can look at that data and find patterns, you can find other ways to optimize what you're doing, which is kind of some of the cool side effects you get out of an IoT solution. We're gathering all this data and we can learn something more from it.
I think last time we checked, we had, I'll see if I can find the numbers once the Q&A started. We had thousands and thousands of photos of cows. We're taking photos from every cow every few tens of seconds, things like that. I'll find the numbers once people are asking questions. As a side project,
before we dive into a side project, actually, we do have a few questions in the chat if we want to take a moment to dive into. So first of all, Alan McCarroy actually, so he asked about using water to clean the camera, but he makes a good point that if you do use water to clean the camera, that's not going to be great in winter, because you're going under -10°C. Anything like that for washing, it's going to get cold, isn't it? So water cleaning cameras, probably not a good thing. Jay has put in a very helpful translation. So when Bryn mentioned as lowering tide, you can see he was wearing togs. Togs is swimwear. It's a Kiwi expression for swimwear. So that explains what that metaphor was all about. And Two Sailors asked the links to the previous IoT for Beginner sessions that got mentioned earlier. I'm just put a link to the chat in there to all our Microsoft Reactor videos. If you search on there for IoT for Beginners, you will find the IoT for Beginner sessions that were run over the past few weeks. I'm doing number 4 on Friday. Babita has another question. Babita's all about the poop today, asking, can the poop be used to generate biogas? So can you actually generate biogas with the poop from farming that you then use to power the farm?
It could be. My son had a book which talked a bit about that, and it was feeding the poop into an anaerobic digester and then using the methane produced to burn to generate heat. We've been talking about using some of the heat from the milk to warm the water, and there are a few other side projects going on. We get an intern. We try and hire a young woman as an intern every holidays. Rosie, our last intern, she worked on spilt milk, which was a project about the utilization of the milking platform. Oh, Kyron's just said that we have 300 and something K pictures. That's good. Thank you, Kyron.
310,000 photos of cows. Yeah.
We had a project called Happy Feet, which was about helping prevent lameness in the cows. Originally, this was called Project Madagascar because you were helping the cows move it. The boss wasn't so certain about that after I said, well, that means you're King Julian. We've got a couple of other projects which are looking at mastitis in cows, condition scoring, cash cow, piggeries. There's one Oinka Goldilocks, which is measuring the weight of cows using machine vision. There's all sorts of
a lot of potential for what you can do here, because once you're starting to get some sensors in gathering data, you just put in more sensors, measure more things, find more stuff.
Yeah, we're looking at adding additional sensors in LoRaWAN. My thing is LoRaWAN and low-speed wireless comms. We're looking at putting additional sensors in so we can, I'm going to sound like a marketer for a moment, we can add value to our solution and give farmers actionable insights rather than data.
Great marketing. But actually, that leads to one question I was hoping to ask you, because these farms are huge. absolutely enormous. And you're saying you've got like power over Ethernet to pass on these things, but what about connectivity? Are there situations where you don't have that hardwired Ethernet cable or decent Wi-Fi, or is the 4G enough? Because you're saying there's rural 4G. Is rural 4G enough for the data you're gathering, or are you using things like LoRa to send data long range? How does that whole data connection work?
The rural broadband's pretty good bandwidth as he reaches over to the side. One of the other things I'm playing around with is
I love your office, by the way, because you've got all the gadgets. It seems every time I talk to you, just reach over and pull out some new cool gadget.
that's a swarm satellite modem. Data volumes are pretty low, but it's good where you've got absolutely no coverage from cellular or Wi-Fi. I'll just lean over to the cover behind
So literally,
me.
that's satellite broadband connectivity, isn't it? So as long as you've got open sky,
Yeah,
you can connect.
that one's real cheap. It's about $5 a month.
That's not bad. What's the data rates for that?
Couple hundred messages a month. It's not something you'd want to use for streaming camera images, but it's fine for measuring soil moisture, stuff like that.
So if you're running, say, a YOLO model on the edge to do this, and you're just getting cow numbers, that's perfectly fine for that.
Yeah. These are the sort of sensors we'll look at integrating. This is measuring the water level in the bottom of a tank, say like a water tank or something. That'll run for 5 to 10 years on batteries, which is pretty cool.
Because that's one of the fun parts about IoT is, how do I power this? And I know for like small sensors, they're looking at powering by radio waves, but if you can run things on low-powered microcontrollers that do it can run for years, that's a good thing. It sort of saves just working out where the power cables go.
If you wanted to measure the depth of the poop, that's a ultrasonic ranger. It'll measure from 20 centimeters up to 7.5 meters. Prospect of a 7.5 meter lake of poop frightens me.
Okay, because you can't see through that poop, can you? It's going to be basically brown liquid, isn't it? So the ultrasonic sensor can get through that liquid and bounce off the bottom. So you can work out how much poop that Babita can then take and create biogas with. Yeah, so Babita has said, I'm giving you ideas to enhance your business. So I think you may have a volunteer to maybe your next intern could be here right now.
This is a close contact sensor. Most power meters and water meters produce a tick every kilowatt or every 100 liters of water. Same thing, 5 to 10 years. And what's this last one I've got sitting here? This is a small bore water flow meter. So if you're hosing down a yard, these come in from 1/4 inch to 3/4 inch and maybe 1 1/4 inch. So you can measure the flow, and that'll last for 5 to 10 years as well. So the whole plan is to collect data off all over the farm and see what other stuff we can spot by accident.
Nice. It's kind of nice seeing all this, because a lot of the talks I give, it's all about intro stuff. So the sensors I have are, here's my little tiny light sensor that's connected to my Raspberry Pi. We don't really get a chance to dig into some of the real world components. So you're actually seeing that you can get these sensors, the industrial type sensors that are designed to last 5-10 years, because that's not just the battery lasting that long, it's the hardware is designed to last for 5-10 years of continuous usage. That's a question from Tusal. That's an interesting question, thinking about kind of resilience of this hardware. Have you ever had any issues with lightning strikes, and any thoughts on protecting gear? So Tusal was working on a farm and the aerial up high took out everything after a hit. So how do you deal with lightning strikes?
Well, over my shoulder, you might see some flashy lights. That's my testing LoRaWAN base station.
Just about.
That's a LoRaWAN base station connected to the Things network. I could hitch it to the ChipStack or Resiat or LoRaWAN. With the big outdoor versions of those, we have lightning arresters, or on other projects, we use lightning arresters, which stop the gear getting blown apart. In a former life, I worked in an aluminium smelter, and there was a lightning strike which took out quite a few of the PLCs and industrial control systems, and they got a consultant, and the consultant said, oh, that's cool. It'll only happen once every 25 years. About 6 months later, there was another lightning strike. And they sent someone up onto the roof of the aluminium smelter. It's one of the few buildings in New Zealand where you can experience perspective. And the person who went up on the roof counted quite dozens of lightning strikes. So they pulled fiber instead of Cat5 so that the lightning strikes wouldn't take out the gear.
Wow. So it is a thing, isn't it? It is something that has to be considered. Anyway, you've got metal in a flat area. It's something you have to think about.
A LoRaWAN base station on a farm will give you somewhere maybe between 10 and 15K range. So this is the very Microsofty bit, Jim. So in a separate parallel world, because I'm a Microsoft guy, I'm running some YOLO v5 models using ML.NET and Onyx on Ubuntu. And this is it looking out into my backyard.
So this is the same model. The YOLO was the model using to recognize cows. This is the same thing, but looking into your backyard. Yeah.
And it's running on an ARM64 device, so not x86 or x64. They released the ARM6. I was on the EAP of the ARM64 version. So you deploy this using Visual Studio Raspberry Pi Debugger, which is very cool, down onto a device running some form of Unix. I'm running Ubuntu or Raspberry OS. There are two versions of it, of this open source project. Most of my employers let me do open source stuff with the gear that they've got or some of the softwares. The fintech I work for, some of the security stuff I built for them, they were quite happy to open source because it wasn't core IP. There are two versions, one which uploads images to Azure storage, it tags them with what it can see. And then there's another one which integrates with Azure Iot Central. The YOLO v5 model, I think, has 80 classes, so it makes for a fairly painful configuration of Azure Iot Central. The dogs are paying attention to the container in my hand, which contains dog treats. The standard YOLO v5 model thinks that Ash is a dog and tiramisu is a bird. Yep. It's also thought that tiramisu was a backpack.
So it shows the problems with these AI models is they're not perfect. Yeah, they make a best guess, but they don't understand dogness.
Yes,
they don't understand why a backpack would be running around chasing its tail. You know?
It caused much mirth in a board meeting where I was explaining to the chairman of the board that her dog was a backpack. I visualized one of those little backpacks like kids have with a dog in it. So that's basically what we do.
Cool. Right, we have a question from Alan McElroy again. But going back to the sensors you've got. So the question is, do these sensors give you a health status or some signal for battery change? Or do you replace on a scheduled basis?
They provide us with an indication of battery voltage. I reach over my shoulder again. So these ones are ones that we use. I also use on other projects. These are $30 US. The batteries will last for a couple of years, but these ones, the batteries tend to have weird chemistry, so you can't chuck them out into standard battery recycling. These ones you can replace the battery. It's got temperature and humidity and then different sensors. That's a sunlight sensor. And then we've got soil temperature sensors, things like that. For the more industrial control focused things, so for the more industrial control focused ones, we've got PLCs. So that's a LoRa rather than LoRaWAN connected PLC. If you want to secure something, these are infrared sensors. They run on a CR2032 battery. They'll run for months. It just depends on how often the door is open and closed, or a small relay for controlling some electronics. One of the interesting ones is this. It's a turn the lights on and off, but it means you can do it without wiring. So you can put one of these by a door and people can turn the lights on without actually having to have a connection. And then you can control the lighting remotely.
Nice. And all these kind of remote sensors where they report everything. there's like the state of the switch. They also can report the battery, so you can then put an alert into Iot Central to say, send me an email when the battery's about to go flat.
Or someone's opened this door. These are the sort of dev kits I work with. That's a Spark ESP32, and that's a rack wireless 4200 module. So I write libraries, because you've chatted to the Nano Framework people.
Not on stream, no, but we've got done some blog posts with them, yeah.
This is a Nano Framework running on an ESP32 with a LoRaWAN module. So I've done a few drivers for the different rack and seed LoRaWAN modules, and for TinyCLR, which is from GHI, and .NET Core on Unix.
Cool, awesome. I would love to carry on chatting to you all day, because it's always interesting, but we are at time.
Oh, yeah, it's
don't want to overlap with the next streams that are coming. But thank you so much for your time. This has been really cool. Thank you, everyone who's joined us today. Please, can you fill in our survey? The link's already been dropped in the chat already. But if you head to aka.ms/reactor/survey, let us know whether you like what you like, what you don't like. We want to make sure that the live streams we're doing are what you want. So please follow the survey link, put in event code 16684 for this event. Thank you very much for joining us. Jay says this was fun, and Jay has also says thanks, Poople. So there's one more poop to wrap up the day. But yeah, David Jones says, thanks, Bryn. Interesting. Alan says, thanks, Bryn. And Jay's like, see what I did there? Yes, we saw what you did there. Awesome. Thank you very much. Thank you for joining us. And see you soon. Bryn, thank you very much for everything. So thanks, everyone. Goodbye.
See you later, Jim.